non-metals. Metals are non-metals, and also transferring of electrons. But on covalent, what happens to covalent? They are sharing of electron between metals or non-metals. And on that note, that is where we are going to start looking at from. You want to look at the genesis of carbon and hydrogen, how they become partner in chemistry, not in crime. You understand? So let's look at it. For example, I said something the other time that we have two types of covalent body, right? We have ordinary covalent body and coordinate covalent body. And coordinate covalent body is what we know as dative bonding. Are you with me? And on this note, what is the difference there? We know that for ordinary covalent body, we have the sharing of one or two electrons. That is when they are ordinary covalent body. But when they are more than two electrons, like 3 and upward, they become coordinate covalent body, or the other name that is known as what? Dative covalent body. Example of ordinary covalent body is water. Are you with me? That is how many hydrogen electrons is oxygen sharing? That is 2, and that is ordinary. But for ammonia, how many hydrogen electrons is it sharing? 3. For methane, how many? 4. They become what? Coordinate covalent body. And because we are looking at hydrogen and carbon, the sharing of the electron coming together, where we have the valency of these is what? 2 and 4. Sorry, this 6. Am I right? Yes. Hydrogen is 1. So 4 atoms of hydrogen make it 4 hydrogen atoms to be able to share with this. Don't forget our bonding. This is the genesis we are looking at. This for carbon. Are you with me? So don't forget the valence is what? 4. It needs 4 other atoms to be able to join it. So we know that hydrogen is having just 4 electrons to be able to share. So we need 4 hydrogen atoms to be able to combine together with carbon to be able to make a good compound. So when we look at this now, all of this will become what? This one, when it is multiplied by 4 atoms, it becomes what? 4 electrons. Let's share the 4 electrons. So this is what? Hydrogen. So sharing of each of the electrons actually connects to this, making it what? And this. So we know that the 4 electrons of this plus carbon, like all these 4 valence right together. So we actually forget on our electron configuration, we have the angular momentum with what? SVD. Is all on what? Okay, element. That's the angular momentum. So on this level, what we need to understand is this. We know that when we're looking at this, we say for S of beta, for carbon, what we have is what? 1s, 1s2, am I right? 2s2, 2p, 2p. I will see now. That is under hybridization. I'm still explaining the genesis of tetravalency of carbon. I'm explaining number 1, right? In terms of the binding side of hydrogen. Do you understand? Number 2 reasons is the types of their hybridization. Do you understand? So we are going to look at them all together. So on hybridization now, don't forget this that S orbital has how many dots? 2 dots. And P orbital has how many dots? So on the slope, for 1s, we have this 1s. like carry it. You understand me? You know the reason. I can't talk about I can read. If I should bias, they are going to see my face. Alright, please. In fact, it's back to it. You understand what I'm trying to say now? I mean, the blocks level. For B, don't forget that S block. And B, we have many blocks. So it's actually so when you're talking about electrons, say 2 electrons, 6 electrons, you understand? You understand? The number of blocks is different from number of electrons. Because it's from 2 levels, 1s and 2s. You understand? So we are going to explain this now. That's what I'm explaining the aspect of multiplication. You understand? So when we have this, for B level, we have 3 blocks. On the 3 blocks, let me say that, let's say 2 blocks, Px, Py, Pz. You don't understand what I mean? It's not the same as 3 blocks for me. So on this step now, don't forget to say that the electron, I will see, are complete. Sorry, not already. 2 blocks, sorry, I need the 2 blocks. 2 blocks for S. I get it started, sorry. So which is the block? We have for 1S so it actually doesn't have a sharing. When you just want to be, you must first, when you're sharing this must be singly what? Share before you share there. see your configuration. According to the number of the electrons, the atomic number of each of the elements, it follows the trend. That's how to know how they are being arranged in the periodic table. Do you understand it? The configuration on which way they are being. You look at it here. What are you going to see here? 1s, then 2s, then 2b, 3s, 4s, and so on. So this is the trend. So that is what they do. So on the stove, we say we have one electron and another one electron. Is that not? Is that not? So on the hybridization, sorry, that's not this. Please, someone should please call attention. Hello. All right, please, let's continue. Why they're talking of excited state? Are you with me? Or ground state? Excited means when someone was jumped from one level to another level. That is from a lower level to an higher level. Are you with me? And when they say something that is ground level, that is the normal standard at which the person is. When something triggers it to move, right? So that is what look at the shifting of the electrons here. You understand? That is, which of these are on a single level without being shared? That is what happens. Let's look at it here. When P is on the ground level, no. That is on the lower level. P is the upper level, then followed by D, the F. Remember that. So if you look at it from the ground level, when there is a trigger of when there is a trigger on it, it excited some of the electron to shift the position from the ground level to the higher level. And when they are occur, there is a loss of electron from there, -1 electron. It will not jump to P. Do you understand what I'm saying? When there is, at the ground state, when there is a trigger, there is something we call the trigger, there is some electrons to leave the position. When they leave the position, they shift to the upper shift position. So that is why they say as excited state, there is the transfer of electron from the ground state to the higher state. Do you understand? And on that note, what is meaning again? So we know that on the ground state we have our S orbital. Please listen, why I'm explaining these two levels is for you to understand. So that when you see a question that revolves what occurs at a ground level or what occurs at an excited state, you should know the reason. Then the transfer of electron, are you with me, from the ground state to the higher state. That is what excited is. You understand? And when that occurs, what happens? I said there is a loss of electron from S orbital. Are you with me? That actually will shift the electron to in orbital. When that occurs, it gives this what? It will be what? With 1 electron, isn't it? Yes. It will be when there's a loss of 1 electron from 2. What will happen to the remaining? It remains 1. And the one that is actually what? Leave that state, goes to the higher level, which is more as what? The upper state. That is for the P orbitals. Do you understand me now? Changing of levels. When there's a trigger on the electron at that state, they jump from that place to a higher state. Right? The electron shifted the position. And when an electron shifts the position to the other orbitals. you understand me now? That is what occurs there. And the level at which they are shifting the position is what we know as excited state. Do you get me? And on this note, if you now look at it, when it is that excited state, what occurs there? You find out that what the electrons are not what? They are on single pairs. On how many blocks? 4 blocks. Are you listening? They are what? They are single pair on 4 blocks. Let me explain again. I use carbon. We are dealing with carbon now. We say that we have a valency of 4. Are you listening? And how does it become balanced? I've used one of the covalent bonding of hydrogen and carbon for you. Now, when it comes to carbon itself, it depends on using its electronic configuration. I said, according to our Albert principle, electronic configuration or energy level, we talk about the blocks level on how they are sharing their electrons. On S electrons, one S has 2 blocks and 2 electrons, right? 2S have how many electrons? 2 electrons. And P has 2 electrons. And don't forget that P is having how many blocks? 3 blocks. I will see. Do you understand me? So, and I say that when you say something, when there's an excited state, at an excited state that what? There is the shifting of electrons from the ground level, the upper level. And when there's a shift of electrons, they shift the position. We've got electrons shifted. It will remove the electron and the other blocks, right? And the block that is adding to what we have to do is increase the number of electrons. You get me? You understand that way? Why you let's do one and let's do okay, type of that discussion. Alright, I actually want to finish those what I interested. But if you understand the first one, you don't understand the second one. I won't want to start it. I want to reject it. Please, you understand? You don't. Oh, okay, let's go on. Maybe as you're going on, you'll get some understanding better. Is that fine? Yeah. So let me explain what so we've not even the same production. You know that at least especially on production itself. Please get to the personal stuff, open there, let me use the SD for you. Do you have a question? Alright. Right, second. Please write. Structure and valency of carbon. Structure and valency of carbon. The electronic configuration of carbon. Structure and valency of carbon. Configuration of carbon. Free of states in the free of states in the free of ground state that is staying on board. It is two. One is 2x, 2px1, px1, 2py1, and 2pz0. Let me put it on the board for you. On the ground state, On the ground state, we are having 1s2, 2p2, 2px1, 2py1, 2pz0. Like that ground state. That is what I explained to you the other time. Right with me. Electron. On absorption of energy, one electron move from the doubly occupied square orbital. Move. On absorption of energy, one electron move from the doubly. When they say doubly, it means double. Move from the double 2s orbital. It's still the same thing. Anyone. Pick anyone. Either double or double. Pick double. 2s orbital into the vacant 2pz. Into the vacant 2pz. You remember I said something. I said when there's a trigger of an energy on the ground level, what happened? It shifted an electron from the 2s orbital, one electron from the 2s orbital, and shifted it to the 2p that is vacant. You understand? So that is what the explanation is saying there. Please, do you understand? Alright. Full stop. Then the configuration becomes then the configuration becomes 1s2 then the configuration becomes 1s2 2s1 2px1 2py1 and 2pz1. So now, do you understand it now? It's very different from what I'm saying. But my English is not there. I didn't make every single one. Alright. Full stop. The 2s and the 3 2p, the 2s and the 3 2p, the 2s and the 3 2p orbital. So we have 1 2s orbital. So how many people we have? So the 3 orbital. Then equalize the energy. They equalize the energy. When they say something equalize the energy, they say they have the same level of energy. If you look at it, they now have 1 1 1. So that is equalization of energy between them. Alright. And then equalize the energy and spread out to the corners. And spread out. And spread out. And spread out to the corners of a regular tetrahedron. And spread out to the corners of regular tetrahedron. And spread out to the corners of a regular tetrahedron. What is the tetrahedron? What of it? Or hydrogen. And on that stage, it's not what attracted hydrogen. Are you seeing that? Oh, just like the number four. Hydrogen, are you available? Think yourself as your when it comes, because we are one, 4 more space for you to come to the so let's try it. Your guys are Vice President, now, I'm going to the question that's all right, so please do you understand what I'm saying now? Do you understand what I'm saying? All right, so on that note now, you find out that there's a shift of electron from here to this, and on this level now, we now have how many electrons, how many blocks that is not fully filled? 4 of them. You understand? There are 4 of them. And the 4 at this level is what we know what? Excited state. This level is ground state. You understand? Where this is still completely filled before absorption of energy. Are you with me now? The energy that is absorbed make it to shift its position. Do you understand me? And when that occurs, that is why it's remaining what? 1. And don't forget, we have an empty space for each of 5, which she said there, so on that one, because they are now what? They are not half filled on the 4 level, they say they are what? Of equal energies. And since they are 4, they call them their what? Spectra. Are you with me? And don't forget, the valence of carbon is what? The valence of carbon is what? Is 4. So, which means that it needs more 4 electrons to become food. Are you with me? And that is where we now talk about hydrogen. That is hydrogen. Hydrogen is just 1 electron. So, hydrogen brings his other sisters to come and marry carbon. You understand? And when they come around, 4 of them, binding with 4 of these, they now become what? 1 carbon with 4 hydrogen. Please, you understand me now? So that is what actually attributed to the tetrahedron. I just explained it. 4. Tetra is what? 4. Valence of carbon is what? 4. And I've told you how it occurs. Hydron is
I did.
That is four shapes now.
Ma, please, where the
Tetrahedron. When you say tetrahedron, what?
I don't know what the drum is.
I said, please, what is that? Is this? Okay, the drum. You can put drum and put water there. So tetrahedron is what? Four angles. Are you with me? And how does it become four angles? It's got the what? Four hydrogen atoms. That is beta ion. So let's use that to represent the structure. Look at the structure of carbon. I'm going to give you two structures. Are you with me? Let's look at it here. Someone tell me, it's supposed to be tetra. It's the form. I do. So on this film, let's look at the sample. Like that one. But a normal day, what we know on a normal day for the normal carbon, then at each different side. I get me. But if you look at it, don't forget when we did pentabonding, you look at pentabonding that I gave you the shape of the name of all the shapes. So what do I say? The shape of methane is tetrahedra. I get me. So tetrahedra. So meaning that it's four angles. You understand? Yes? Okay. This 109 28 I think like some other just like what they say one like something. I gave you like 109. And it's still 109. Still 109. And they'll not even give you like any application, they'll give you the point. They give you like 109. So that is the number angle. It doesn't also change. That is the same angle that it is. Alright, it's not understood. Please. Any question? Any question? So we know this to be what? This tetrahedra. So when they say something is tetrahedra, what is the difference between tetrahedra and tetrahedra? It's not the same thing. It's this form angles. You understand? That is what it means. Is that understood now? So that is the genesis of hydrocarbons. Do you understand now? So at least if they should ask in different ways, you know how to say it. Now, what if they ask when it pertains to hybridization? Are you with me? Someone asks a question. Let's write. Let me give you the point. See here. Let's continue. This is term.
My name.
Continuation. Continuation. The structure is a part of it. Continuation of what I'm giving to you under structure and valence of carbon. This is termed as sp3 hybridization. This is termed as sp3 hybridization. This is termed as sp3. This is termed as sp3 hybridization. That is, there are few half electrons in the orb. There's no one that is vacant. Because if one is vacant, it means we are having the orb. Right? So it's what sp2. But now we are having sp3. So now we know that for hydrocarbon, the hybridization is what now? sp3. Do you understand now? Do you get the question now? Now it means that sp3. Full stop. The overlap of these four orbitals, the overlap of these four orbitals, we singly occupied orbital, that is singly, with singly occupied orbitals of other atoms. We singly occupy orbital of other atoms. Other atoms such as hydrogen, Alright, can you hear me now? I said the overlap of these four orbitals, we singly occupied orbitals of other atoms, such as hydrogen. Leads to a tetrahedral molecule. Such as methane. Leads to tetrahedral molecule such as methane. So I'll explain that on the board. Methane. Such as methane, the symbol of what is full stop. The hydrogen carbon bond, all the hydrogen carbon bonds, hydrogen, single bond carbon, single bond hydrogen. You know, it's actually a single bond. All true. You understand me? So all the bonds are bonds. All the bonds are 109 degree, 28 minutes. That is what I'm written on the board. 109 degree, 28 minutes. 109 degree, 28 minutes. Which is known as tetrahedral angle. Is no, not unit. That is the angle. That is it on the board. Which is known as tetrahedral angle. So now, know about structure, right? We're going now, right? So they ask in electronic configuration, be able to tell them an expect electron orbital, p orbital, are you with me? To make it that is what SP hybridization. transform. And the story behind it. So if my son is not around them, you should be able to know which one actually still into it. And because there are four space for it to attract other atoms, that is why use the one that has four atoms that you can share with to become stable. Is that understood now? Alright. So now let's go into our topic. Hydrocarbon. Yes. What we just did now is what? Structure and valence of carbon. We have hydrocarbon. Hydrocarbons are compounds of carbon and hydrogen only. Hydrocarbons are compounds of carbon. Yes, hydrocarbons. Hydrocarbons are compounds of carbon and hydrogen only. Hydrocarbon, subtopic under organic carbon. We say hydrocarbon is the compound of carbon and hydrogen only. They are derived from petroleum. They are derived from petroleum, natural gas, and coal, C-O-A-L, and coal, and as their source. Yes, they are derived from petroleum, natural gas, and coal as their source. There are two major groups of hydrocarbon. Namely, aliphatic hydrocarbon. There are two major groups of hydrocarbon. Number one, aliphatic hydrocarbon. A-L-I-P-H-A-C-I-C. Number one, aliphatic hydrocarbon. Number two is aromatic hydrocarbon. Aliphatic hydrocarbon and aromatic hydrocarbon. Aliphatic hydrocarbon can be gases, liquid or solid. Aliphatic hydrocarbon can be gases, liquid or solid. They are straight shape, branch chain, or cyclic, full stop. Or cyclic. E.g. Alkanes. appears and K appears and times. Full stop. Aromatic hydrocarbon. Aromatic hydrocarbon. There are all. They are like they're oil like they're oil like that looks like made from what food or right? Benzene is the same member. Benzene simplest member. Benzene simplest member. Benzene. Benzene. All right. So member. All right. So these two groups now. You understood what I said, right? We have aliphatic to be straight or branch or cyclic. That if it's cyclic does not mean that it is aromatic. You understand? Aromatic is only cyclic with double bond. Are you with me? Aromatic is what? Only cyclic. No, there's no right that there. It's cyclic with only double bond. And the main example there is what? Benzene. So, and also, they told us what they're like. Let me say that they're physical properties. They say for aromatic, they are like what? Oil. Are you with me? They are like oil. And for aliphatic, what are they? They can be solid, they can be liquid, they can be gaseous. Do you understand? So that's the differences there. Now, we want to enter the main structure and component of hydrocarbon. Homologous series. These are LOP. I want us to concentrate because we have a lot to cover. And time, your question will make us be able to achieve more. Homologous series. What do you say? Homologous series is the member of organic compound. Is the member of organic compound with the same general formula. Member of organic compound with the same general formula.
Member of organic compound.
Organic compound with the same formula, the same general formula, and chemical properties. Chemical properties. They have the same general formula. They have the same chemical properties, but not the same physical properties. Are you with me? The same general formula. The same chemical properties according to the members. Are you with me? Different physical properties. Different physical properties. physical properties. What do they mean? That is the boiling point, the melting point, the solubility, and so on and so forth. Are you with me? So that is, don't forget, there's something we are going to look at now. As we are starting our entry to it, I'll be explaining them one after the other. As there are increments in the carbon atoms, the physical properties will also change. Are you with me? The more the carbon atom increases, the more there will be changes in the structure, the more there will be changes in the physical properties. That is what they mean. And but because they belong to the same group, same family, are you with me? Then they are going to share the same properties in terms of the physical, chemical appearances. Alright, please, let's go on. So, homologous series members. We know we say that homologous is the what? Is a group of organic compounds. So the group is what we want to look at now. The group is what we want to look at now. So groups of homologous series. We have alkanes. We have number 2. We have alkanes. Alkynes. We have alkanols. Before we go on, let's stop on this quick. You know, I told I'm not the only one to take it. So we are going to take it bit by bit. Let's stop on this quick. You have like a level of them. We have alkanol, we have alkanoid, we have alkanoids, we have alkanoid, we have what other alkan? Alkanals, we have alkanals, we have another alkan. I've said alkanoid, which is also known as what? Ester. That is alkanol, that is alcohol. So, are you with me? So, we are going to start with the first three. We are going to start with the first three. So that we take it bit by bit. And when we are looking at this, don't forget to say these are what example of aliphatic hydrocarbon. Are you with me? That can occur as what? A straight shape, that can occur as branch shape, and that can occur as cyclic ring. It's not shape, it becomes ring when it's cyclic. So it's called a cyclic ring. And on this note, we are going to pick them one after the other. Are you with me? Okay, so on this week, before we go on, let's look at some things about them. Let's try properties. Properties of alkanes. That is what we want to write now. Properties of alkanes and alkynes. Alkanes 3. You know, we're going to look at the first 3. So on this 3, let's look at the properties. In top, let me write it down. We should write this forward. Yes. Okay. Other. So like George, look at how it looks like. You understand? Look like it's only repetition. Why does he like it? It's tabular form. Okay, no problem. Let's start with our case. General formula is CnH2n plus 2 for our case. So we are starting with our case as you said. That's general formula of CnH2n plus 2. It is a saturated number 2. It is a saturated hydrocarbon. It is a saturated hydrocarbon. When they say it's saturated, it means that it is with a single bond. It doesn't have any other reaction on the going. You know, when we say that hydrogen bond, obviously, so far it's a single bond that is there. You know, others we increase the bond of. Yes? When there's no loss of hydrogen, let me use another time. When there's no loss of hydrogen at all, a carbon must have how many hydrogen atoms? 4. 4 becomes stable. You understand? So, yes. It can have branches. So it's not. Yes. It's only the one that will differentiate from others. When they say saturated, it means that the single bond is in all, no matter what. Alright. That is saturated at the carbon, that is one bond. Can you hear me there? How do you hear? Number 1, that is what I'm written on the board. Number 2, I said it is a saturated hydrocarbon. That is only single bond. That is only single bond. Exists between adjacent carbon atoms. Only single bond. Only single bond exists between adjacent carbon atoms. Only single bond exists between adjacent carbon atoms. Number 3. The reaction now. Number 3. It undergoes substitution reaction. Adjacent carbon atom. Number 3. It undergoes substitution reaction. When the reaction are substituting each other, we don't have another chemical reaction. Substitution reaction now. Substitute. When the reactants are reacting together, there's what? They substitute each other. A go to B, B go to C. You've done that. Let's do we are going to please. Let's finish with the stories. The story is actually giving you. Where do I stop? Alright. Number 4. That is the bonding effect. Number 4, bonding effect. Right colon in front. Bonding effect. Bonding. By the. Yes. Number 4. Right. Bond. It bonds with non-luminous flame. 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 That's where undergo what? Bonding effect. What do I say? B-U-R.
How is bonding effect?
Take a methane, put it in bonding. The flame will tell you that it is non-luminous. Have you not done practical in secondary school? So what's you didn't undergo any reaction or methane? Okay, let's use an example. Our bossing funnel. You know our bossing funnel now? Our bossing plate. Is it born out? I'm trying to remember what I said. Are you with me? When they put it in there, the occurrence, which we know as that is the reaction that it undergo, is what they record down. That is the kind of reaction that occurs when it undergoes the process of burning. When you put it in heat, let me use that for example. When you put it in heat, so this is the reaction that actually will take place. You know, it says the properties. What occurs to it when it undergoes some activities. You understand? So that is what happens.
This is not is it that does not emit like light or light emits?
When they say something is luminous, what does it mean?
Sunlight.
So when they say none, what does it mean? That is opposite of what occurs of luminous.
When if you take your you see the reflex light from
Yeah, explain non-luminous. I said
what I see the picture of non-luminous light.
What's it? It's not alone. Alone. Let me understand. What's the question?
Sometimes when you have like both sometimes you mean like orange or red. So this one is like more like
No, it's true now.
or light is just I want to know
It's true. I agree. And normally, when you say something is luminous, everything of light, right? Which is actually a blue flame. It's kind of blue. I agree.
man, what's the difference?
Yeah. So it's when there are impurities, like changes flame towards yellow. Are you listening? When there are impurities, it changes flame to yellow. For example, I'm going to get to that. For example, let's look at our gas. When you just got your gas and you on it, I'm talking of the seed on it, everything. What will happen is to come out blue, right? Without impurities. Impurities occurs when there's a drop of water and the metal becomes what? Rusted. You understand? So it means that there is no reaction that doesn't change it. It's not that it doesn't emit light, it's emitted. But it doesn't change its flames. You understand? That is the reaction when you put the tape on it. Let's practicalize it. We have the lamp. Yeah. Well, you have the gas. Put it down. Let's first sit down by your tape. No, seriously, the sound is in the lab. Or for pharmacy. You know that. So, alright, so please, where do we stop, please? Number 4. Is it number 4? It does not undergo polymerization. It does not undergo polymerization. Number 6. Reaction. Wait, are we going back to chemical reactions?
No, ma'am.
Okay, don't worry, please